Today we're going to cover Chapter 3, Section 5, which is finding and using slopes of lines. Now, you learned about slopes of lines and equations of lines and all these things in Algebra 1. However, today we're going to kind of review what you learned, but now we're going to look at it from a geometric perspective. We're going to talk about theorems that might have created the facts that you used in algebra for your lines. So first we're going to start out with a review of the Algebra 1 topics that are going to pertain to this section. So first is, what is slope? So the slope now of a non-vertical line, okay? A vertical line is an exception, okay? A vertical line is a line that goes straight up and down, and it is special, okay? So whenever we talk about lines, we're really talking about every single type of line except a vertical line. And we will go into more detail on that in a subsequent slide, okay? But the exception to everything we're talking about is vertical lines. So everything we're referring to are non-vertical lines. So the slope of a non-vertical line is the ratio of change in y to the change in x. So what that means is if I start here, let's say at this point, x1, y1, and I go to this point here, x2, y2, I'm going to have a change in my y value. In other words, I know that my point from the original, right, over to the new one is going to have a rise. I'm going up. And I know that I'm going to be going to the right as well. That's my change in x, and that's my horizontal change. Y has everything to do with vertical, and x has everything to do with horizontal, because vertical is up, down, right? And horizontal is side to side. Now, I don't use really the formula of x1 and y1 and all that, but the official formula is the slope represented by the letter m is the change in y, which is the vertical change, over the change in x, the horizontal change. We also know this as our rise over our run, okay? We can also write this also as delta y over delta x. Delta in math represents change. So the change in the y's over the change in x. And so I'm going to work with you a little bit and show you, instead of labeling them as x1, y1, and x2, y2, I'm going to show you how I do it so that you can kind of keep it organized every time. Before we get to actually calculating the slope, though, we want to get some general idea about a slope. A positive slope, as I move from left to right across the x-axis, notice that my original line is going up from left to right. That's a positive slope. If, as I'm moving from left to right, my line is going downward, then that is a negative slope. If, as I move from left to right, there is no change at all in the height of my graph, it doesn't rise up or go down, then this is a zero slope. My slope equals 0, and it's a horizontal line. And then as I move from left to right, notice that my line has no run at all, okay? This is a vertical line, and my slope is what we call undefined, okay? And an undefined slope is a very special case, okay? So again, my vertical line has an undefined slope. So my slope can be a positive number, a negative number, a zero slope, which means no rise, only run, okay? And no change in, basically no change in y, only changes in x, and then undefined, which means no run. Means rise and no run, no change in x. And again, we'll talk about why it would be undefined. So there is a theorem here that we use in Algebra 1 all the time, but we never told you it was a theorem. And the theorem says, in a coordinate plane, two distinct non-vertical lines, again, remember, vertical lines are our exceptions, so it's all lines except vertical. Two distinct non-vertical lines are parallel if and only if they have the same slope. Notice this is a biconditional. What this means is it can be used in either direction. In other words, if you're told the non-vertical lines are parallel, then they have the same slope. If you're told two lines have the same slope, then you know that they're parallel. So you can go from one order to the other. Any two vertical lines are parallel. So again, in non-vertical lines, you need to prove the slopes are the same. But anytime you have two vertical lines, you know that they are parallel. Both of them have an undefined slope, so I can't say their slopes are the same, but I know that they're parallel. So in this picture here, notice the little triangles. This is telling me that those two lines have the same slope. So the slope of the blue line must be the same as the slope of the red line. Now, we get to perpendicular lines. And again, there's another theorem for these. We use this in Algebra 1, but this is where it comes from. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Now, you might not have learned it that way in Algebra 1. You might have learned that the slopes are opposite reciprocals of each other. So, in other words, let's say the slope of line 2 here, the red slope, is 1/2. Well, then that means the slope of 1, the blue slope, is going to be the opposite reciprocal. The opposite reciprocal means the opposite sign, which means negative, and reciprocal 2/1. Now, mathematically, this is what they're saying. 1/2 times minus 2/1 has to end up equaling -1. And notice that it does. So mathematically, if your slopes have a product of -1, they are perpendicular. And you can also see it, instead of the product of -1, you can see it as opposite reciprocals. And that way you don't have to actually multiply them. So opposite meaning opposite sign. And reciprocal means flipped fraction. Okay, and so that's what that means. The second kind of interesting thing here is this one that says horizontal lines are perpendicular to vertical lines. So even though we know that perpendicular lines have a product of -1, that doesn't exactly work out for horizontal lines. Horizontal lines go here, and remember that their slope is 0. Well, they're not going to have a product of -1 with anything, because anything times 0 is 0. So horizontal lines and vertical lines, which are undefined, those two lines are always perpendicular. So they don't meet the requirement of having a product of -1. Their slopes aren't opposite reciprocals of each other, but they are in fact perpendicular lines, and it makes sense. So again, this is kind of the one exception to the rule above. So now we're going to fill in some of these spaces. So it says complete with sometimes, always, or never. The slope of a vertical line is sometimes, always, or never 0. It is never 0. It is always undefined. Okay. The second one. The slope of a horizontal line is always 0. The slope of a line that rises to the right is always positive. And the slope of a line that falls to the right, which means as you go from right to left, it goes down, is going to be always negative. Okay. Now, a way to kind of remember slope, you might think he's silly, but it works every time. Think of this face. Okay. So we go, the line rises from left to right. That's a positive slope. It goes down from left to right. That's a negative slope. A vertical line is undefined, and a horizontal line is 0. And if you can think of Slope Man, I didn't create this. This is off the internet, but it's a great picture to help you kind of recognize the 4 slopes that we're going to be talking about. So now let's find the slope of a line through 2 points named. Now this is where I differ from the whole x1. Like they would normally make this x1, y1. They would make this x2, y2. And you would have to remember the formula. You would have to say, okay, m equals y2 minus y1 over x2 minus x1. And so you're like, okay, y2 is 5, y1 is 4, x2 is minus 4, and x1 is minus 3. And so you're like 5 minus 4 is 1, negative 4 minus negative 3 is negative 1, and so my slope is negative 1. And that's fine. Oops, negative 1. And that's okay to do. The only thing is I find that kids get really tripped up with the whole x1, y1. And so what I have kind of taught you guys to do is anytime you have to do any kind of computation with ordered pairs, my suggestion is to write them one on top of the other. So for this one, I'm going to do it this way. I'm going to do 6, negative 3 is one ordered pair, and I'm going to do negative 1, negative 2 is the other. And when I'm finding slope, I'm going to do my top y minus my bottom y minus 3 minus negative 2, and my top x minus my bottom x. And so I know this is plus, 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 and I get minus 1 over 7. And so I know my slope is minus 1 over positive 7. And so that's a negative slope. So whether you want to label them x1, y1, or whatever, it's always going to be the same as long as you keep the order appropriate. So again, I'm going to keep doing my top minus bottom just because I think it's much simpler. You can label them and do it that way if you prefer. So I'll do this one, C, top minus bottom. So again, I have 8 and negative 4, and I have negative 3 and negative 4. And I know that my slope is, again, my top y minus my bottom y, and it's my top x minus my bottom x. Again, minus minus is always plus plus, so I get 0 on the top, and I get 11 on the bottom. Well, 0 divided by 11 is 0. And so I know that my slope is 0, and I know this is a horizontal line. Remember, a horizontal line has a rise, has a run, but no rise, right? Notice my y's don't change. So my y's are always minus 4. The only thing that's changing is my x's, which makes this accurate, okay? Makes it consistent. So then we go to the last one, and we're going to find the m here. Now this one I'll do it the x1, y1 method to practice you a little bit on that one, y2. And so I know that the slope here is, again, y2 minus y1 over x2 minus x1. And so I'm going to get 9 minus negative 2 over negative 6 minus negative 6, plus, 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 11 over 0. And so here is where we get undefined, which means that this is an undefined slope, which means it's a vertical line. Now, you might say, again, and if you look at it, you notice your x isn't changing, so there's no run here. Well, when there's no run, it's vertical. This is just a line straight up and down. And so you might be saying to yourself, well, why is C 0 and why is D undefined when they look very similar as problems? Well, let's think about C. If I have 0 divided by 11, that looks like this. And you might say, okay, when you're solving this, how many times does 11 go into 0? Well, 0 times. So you know the answer is 0. But if I do it, this one, if I do D, and I say, well, how many times does 0 go into 11? That's an undefined answer. Does 0 go into 11 0 times? Does it go in 11 times? Does it go in an infinite number of times? And truth be told, there is no definite answer. So it's an undefined answer. And therefore, it's an undefined slope. So that's where undefined comes from. And that's why vertical lines are different than all others. All the other ones, you can compute a slope. This one, you cannot get a definite slope, so it comes out to being your undefined. The last question that I get asked a lot is, what if I switch the order? If I go back to, let's say, B that I did here, this is B. Notice that I put 6, negative 3 up top, and I put negative 1, minus 2 on the bottom. What would happen if I switch the order? What if I put minus 1, minus 2 as my top, and 6, minus 3 as my bottom? And I want you to see how you're going to get the exact same slope. Remember, I'm going to do top minus bottom, so minus 2, minus negative 3, over, and I'm going to do minus 1, minus 6. And plus plus, and you see that I'm going to get a positive 1 and a negative 7. And so 1 over negative 7 has the exact same value as negative 1 over 7. It's still negative 1/7. And so the order, which one I put first, doesn't matter. So if I want to call this x2, y2, and I want to call this x1, y1, that's fine too. So again, you don't fear that part of it. Okay, there's no right or wrong way of setting x1 and x2. Now, I'm going to complete the table for r is parallel to s and if r is perpendicular to s. So when I look at this graph, what it's telling me, or this chart, it's telling me that the slope right now for r, for line r, is -0.5. So if r was parallel to s, it would be the same slope, right? And if r was perpendicular to t, it would be the opposite reciprocal. Sometimes we call that negative reciprocal, right? That's another way to look at it. Or remember that the product of the two would equal -1, okay? And so if s has the same slope, then I know it's going to be -0.5, and the opposite reciprocal is going to be the opposite sign, so positive, and I'm going to flip the fraction 2 over 1, or just 2, okay? If the slope of t is 1/6, remember that r is going to be perpendicular to t, which means it's going to be the opposite and the reciprocal, 6 over 1, which just makes -6. And then again, s is going to have the same slope as r because it's parallel. So the slope of s is going to be -6. Okay. In C, again, if s is 1/5, I know that if r is parallel to s, it's going to have the same slope, so it's going to be 1/5. And then t is going to be perpendicular to it, which means it's going to be the opposite reciprocal, or -5. In D, s is -4, so again, r is parallel, so it's going to have the same slope. And then t is going to be perpendicular, so it's going to be the opposite, which is positive, and the reciprocal, which is 1/4. Now, we don't really have to write positive. We only write the sign if it's not positive, right? So I can just write it as 1/4. Either way is fine. Now, here's a letter, which kind of throws me off, but basically I know that if t is a, and I know the slope of r is going to be the opposite reciprocal of a, so -1 over a. And s is going to have the same slope, so it is also going to be -1 over a. Lastly, in F, I see that line T has a slope of 3b over 4, which means, again, if r is perpendicular to it, its sign or slope is going to be the opposite reciprocal of it. So it's going to look like that. And my parallel line S is going to have the exact same slope. When you are writing a negative, you can, like, let's say it's 4 over 3b, you could write it as -4 over 3b. You could write it as 4 over 3b and have the negative kind of out here. And you could technically do -3b in the bottom. Obviously, this is preferred, the first one, but all three of those equal the exact same thing. So in example 4, it says if r is parallel to s and r is a horizontal line, what is the slope of s? Well, again, if r is a horizontal line, then we need to figure out what is the slope of r. If it's a horizontal line, the slope of r is 0. So if s is parallel, the slope is going to be the same, right? Because parallel lines have the same slope, so m is going to be 0 as well. So in this slide, we get to perpendicular lines. It says if k is perpendicular to n and n has no slope, well, or no, not no slope, n has a slope of 0. Well, a slope of 0 means a horizontal line. What is the slope of k? Well, if they're perpendicular to each other, I know that k must be a vertical line, because remember that horizontal lines and vertical lines are perpendicular to each other. So if k is vertical, then k has a slope that is undefined. Okay? So k, the slope of k is undefined. Remember that a zero slope and an undefined slope are perpendicular because they're a horizontal and a vertical line. This is my So now again we go back to kind of algebra 1 and we're like, okay, here's slope-intercept form of a line. It's y equals mx plus b. M represents your slope and b represents your y-intercept. It's where you cross the y-axis. So I'm going to do some on the next page, but remember, this is your y-axis, right? This is your x-axis. And if you have a line that, let's say, goes like this, right, we know that this is where it crosses the y-axis, so this is b, okay? And our b can be written as an ordered pair. It would be x is 0 and y is b, or you can just say that the y-intercept equals b, okay? And then again, your slope is going to come from, you're going to need to count, rise over run, or you're going to need another point. So if I ask you to find the slope and y-intercept and then graph, we're going to graph on the next slide, but let's first find the y-intercept and the slope. So if I start out with A, I'm going to do A in blue, or in red, okay? If I have 2x minus 3y equals 6, and I'm solving for slope and y-intercept, I'm going to want to put it in slope-intercept form, which means I'm going to need to solve for y. And in Chapter 2, we practiced solving for specific variables in an equation, and this is great practice for here. Again, you also did this in Algebra 1. I'm going to start by, if I need to get y by itself, I have to start by subtracting 2x from both sides. When I do that, I'm going to get minus 3y equals minus 2x plus 6. I like putting the x in front because that's how the formula is, okay? And then I'm going to divide everything by negative 3. And when I simplify, I'm going to get y equals, now I have minus 2 over minus 3, which is just going to be positive 2/3. A minus over a minus is a positive. And I'm going to have plus 6 over negative 3, which simplifies to negative 2. And so now I'm able to look at A, and I know that my slope is 2/3, and my y-intercept is negative 2. And I'm going to go to the next page, and I'm going to graph that line. Again, it's going to be a slope of 2/3 and a y-intercept of negative 2. Now, I'm going to actually solve all of them first, and then I'll go and graph them in the next slide. So in B now, again, notice B is already in y equals mx plus b form. So this one I just have to identify that my m is negative 1/4 and my b equals 2. So I know that my graph is going to have a negative slope of 1/4 and my y-intercept is going to be 2. And my third one, notice here that it is solved for y, but I'm missing my x component. Well, what that means is that y equals negative 3. Then what's missing is my x, so think of it as 0x. Well, my m is 0, right? So m is 0, which means it's a horizontal line. And my b is negative 3. And I'll show you what that will look like in a drawing. So if you notice here in the corner, I wrote the slope and the y-intercept from the previous slide. So the first thing I'm going to do is I'm going to graph A, the first equation that we got to. And I notice that if my y-intercept, I'm going to start with my y-intercept, is negative 2, then I know my first point on my graph is 0, negative 2, or that negative 2. Remember, this is my y-axis. This is my x-axis. And so, again, now I have a slope of 2/3, and this is the easy part of this. If I know that if my slope is 2/3, I know that my change in my y, or my rise, is positive 2, and my run is positive 3. That means I'm going to go up 2, and I'm going to go to the right 3. Okay, so my rise up 2 and to the right 3. Here's my second point. And I'm going to just keep doing that until I get enough points that I can draw a pretty good line, right? And so I just kind of draw my line through it. It's a terrible line. Again, try to be accurate, but it's something like that. Notice I have a positive slope, which I knew. I go up from right to left, and that's the picture of my graph. Okay, now I'm going to go to the second one. The second one says I have a y-intercept of positive 2, so that's my first point, and my slope is minus 1/4. Now, a minus 1/4, I know that's, again, my rise over my run, and I know that I'm going to go down 1, and I'm going to go to the right 4. Up is positive, down is a negative for rise, and right is positive, and left is negative. So if I have a negative 1 over a positive 4, I'm going to go down 1 this way, and I'm going to go 4 to the right this way. I'm going to go down 1 and 4 to the right. I'm going to go down 1 and 4 to the right. And that's what mine would look like. Now, could I switch it and go the other way? Yeah. If I have an m of negative 1 over 4, I could also make it positive 1 over negative 4, which would mean up 1, left 4. And look what happens if I start at 2. Up 1 and left 4. Up 1 and left 4. And notice that my slope stays the same, and I can still draw my line through here. And I know my lines are terrible. I'm sorry about my terrible non-straight lines. Okay, but again, that's basically it. So you would just, once you draw 2 points or 3 points, you should be able to draw a line right through it. So that's the second one. Now the third one, notice that it has, I'll do it in green, right? Third one has a slope of 0 and a y-intercept of negative 3. So I know my first point is at negative 3, and a slope of 0 tells me it's a horizontal line. And so I know that this would be represented like this, a horizontal line. There is no rise in a horizontal line. It's just straight horizontal through negative 3. And there are my 3 lines that I drew from the previous page. So when we get to this problem where they want us to write an equation, this one's going to be a little bit more challenging. Notice they want us to write an equation of a line passing through point negative 1, 1. So the line that they want us to write goes through negative 1, 1 and is parallel to a line with this equation. Now, the only reason they're telling us about this equation and they're telling us that the line they want is parallel to it because they want us to use the slope from this equation. Okay? We know that parallel lines, right, have the same slope. Right? So if the slope of this line is m is 2, then I know that the line or the equation that they want us to write is also going to have an m of 2. So now I know the equation they want has to go through point negative 1, 1 and has to have a slope of 2. And so there are 2 ways that I can solve this. If I use the existing method that I have, the only equation that you've really covered right now is y equals mx plus b. And the problem is here that if I have an m of 2, right, I need a b and I don't have it, right? Because all I have is this point, and this point is an xy combination. It's not b, it's not a y-intercept. Well, one method I could do is I could plug that x and y into this equation here, and I could find b. So I'm going to do that. I'm going to plug it in. I'm going to do y is positive 1, m is 2, which I already established that, x is negative 1 plus b. So I'm going to get 1 equals negative 2 plus b. And if I add 2 to both sides, I'm going to be able to conclude that b equals 3. So now b is 3. Now that I know that b is 3, I'm able to do the equation. The equation that they want in slope-intercept form is going to be y equals, y equals 2x, because 2 is my slope, plus 3, because b is 3. My final equation always has to have the variables x and y in them, okay? But this way, I was able to use what I had. I was able to use the point to find b once I knew the slope. So find slope, then use the slope to find b. This is one method of doing this. Maybe your teachers taught you this, maybe they didn't. There is another way to find this, and this is how I taught my students in Algebra 1. So if you're one of my students, you probably learn this a little different. There's another type of equation of a line. Right now, you've learned y equals mx plus b. This one uses slope and y-intercept, and it's called the slope-intercept form. But there's another formula. It's y minus y1 equals m times x minus x1. This is called the point-slope equation of a line, okay? And what's different here is instead of using the slope and the y-intercept, it uses a particular point. They call that point x1 and y1, and they use slope. So again, in this problem, notice we were given a point and a slope. And so really, this point-slope equation could have been used as well. In this equation, y1 is the y value of the point you were given, which was 1. M is 2, you already knew that. And then x minus the x value of the point you were given, which is 1. Notice what happens when I clean this up. Okay, x plus 1. Now I know I'm going to distribute the 2. So 2x plus 2. And I'm going to add 1 to both sides. And notice what I get. Y equals 2x plus 3. And I'm back to the same equation in slope-intercept form. So point-slope form, okay, is another, or point-slope equation is another way to find the equation of a line in slope-intercept form if you're not actually given the b. So you can either use this method to find the b and then plug it in, or you can just go to point-slope form and do it from there. So I'll do it both ways. You can figure out which way works for you best. All right, here we have another equation. We'll do both forms, okay? So first of all, write an equation of line J passing through point 2, 3. So it's going to go through 2, 3. That is perpendicular to line K with the equation 2x plus y equals 2. Well, you know that perpendicular slopes are going to be opposite reciprocals of each other. Opposite reciprocals, or have a product of -1. So I'm going to need to know that slope. So if the equation of the line that it's perpendicular to is 2x plus y equals 2, I'm going to need to know the slope. So I have to kind of put this in slope-intercept form to figure that out. And I'm going to get y equals minus 2x plus 2, which means my slope is -2. So I know that the slope of the equation I want to write is going to be the opposite reciprocal of that, which is going to be positive 1/2. Now that I know the slope of my line, I don't need to know anything else about this line that it's perpendicular to. Now I just need to figure out how I'm going to solve for it. So if I just want to use slope-intercept form, okay, or the slope-intercept equation, I'm going to solve it this way. I'm going to start with y equals mx plus b. I'm going to plug in the x and y that I was given. So y is 3, m is 1/2, x is 2, plus b, and I get 3 equals 1 plus b, and if I subtract 1, I get that b equals 2. And if b equals 2, I know that my equation is going to be y equals 1/2 x plus 2. And so this, I think, is the easier way to do it. But again, it's always good to know how to use the point-slope form. And so I'll show you that one as well. So again, if I was to do this using the point-slope form, point-slope form of the equation, what I would do first is I would write it y minus y1 equals m times x minus x1. And again, my y1 is my y value in my point that it goes through. My slope was 1/2, and my x is the x value of the point they gave me. So I start out by distributing the slope, and I'm going to get 1/2 x minus 1, and then I'm going to add 3 to both sides, and I get y equals 1/2 x plus 2. either one, notice, it gives you the same equation. Some of you learned it this way, which is a little bit more traditional. SATs often ask you for equations of lines in point-slope form, so it's not a bad thing to kind of remind you of this form. This is the kind of the shortcut to it, the quick way to get to it. Either way is fine with me. And lastly, we're getting to find the distance from the point 1, 0 to the line y equals negative x plus 3. Now here, this is going to be quite a challenge, right? So again, let me just kind of draw this out for you a little bit to see, right? Obviously, I want to kind of give you a visual. So here's our x-axis. Here's our y-axis, rather. Here's our x-axis. Notice the equation of this line. Let me kind of draw it. I know that my m is negative 1 and my b is 3. So I know that my y-intercept is here at 3. And if my slope is negative 1, it's, let's say, negative 1 over 1. So I know that my rise is going to be 1 down and 1 over, 1 down and 1 over, 1 down and 1 over. That's a terrible line, isn't it? But anyway, it's going to look something like that, okay? That's what that line looks like. This is the line of y equals negative x plus 3. Now, point 1, 0 is located here. And they want to know the distance from 1, 0 to the line. Well, remember that the distance is going to have to be a line that is perpendicular to the original line, the original red line. Well, so I have to figure out at what point, right, does that line hit? What's that coordinate, right? And once I know the coordinate, I'm going to have to find the length of that, if that makes sense, right? So had I done this on a proper coordinate plane, which you would sort of have to do, right, you're going to recognize that the coordinate of a line perpendicular there, I'm going to have to try to do this line. I'm going to have to envision this line that I have to make, right? This line starts here at 1, 0. So that line goes through point 1, 0. And it's going to have a slope that is an opposite reciprocal to this one. So the slope of my line is going to be a positive 1, okay? So, or 1 over 1. So if I start at 1, 0, then if I go up 1 and over 1 here, I'm going to get to probably 2, 1. And if I had done this on a graph, you would have seen it, okay? So that point right there is 2, 1. So my starting point was 1, 0, and I intersect the red line at 2, 1. And now I'm able to find the distance between those 2 points. Because again, remember the distance is the difference of my x's squared, 1 minus 2 squared, plus the difference of my y's squared. So again, I'm going to get negative 1 squared plus negative 1 squared. That's going to be 1 plus 1, or the square root of 2. So I know the distance from 1, 0 to the line, this blue line here, is going to equal the square root of 2 units, whatever that might be. But again, that's kind of tricky, right? So I need to have a coordinate grid here so that I can figure out where they intersect. I'll have to use the line they gave me to find the slope. I'll have to find the negative reciprocal of that slope because I know that's going to be the line perpendicular to it. And then I have to kind of do my slope all the way until I manage to get a point that actually is on the line. And once I have that, now I have 2 points, right? These 2 points here, and I can find the distance between 2 points using the distance formula. So this one's a little bit challenging, for sure.